Valves that are used to regulate the flow of fluids through process systems often have to be opened, closed, or throttled. And in many situations, they need to be controlled from a remote location. That's where actuators come into play. Actuators are mechanisms that are used to move or control other devices, like valves. Actuators allow valves to be repositioned from a central remote location, such as a control room, so they reduce the need for operators to operate or reposition valves by hand. There are a number of different types of valve actuators. Typically, a solenoid actuator, or simply a solenoid, is used for on-off control of a valve. Solenoids can position a valve from fully open to fully closed quickly, so they're particularly useful for emergency shutoff of valves. A solenoid actuator consists of a wire coil, a spring, an armature or core, and a stem which is connected to a valve. When current flows through the wire coil, it creates a magnetic field around the coil, which in effect becomes an electromagnet. The armature, which is a solid metal core, is attracted to the magnetic field. This attraction pulls the armature toward the center of the coil. As the armature moves, it compresses the spring and moves the stem, opening the valve in the process. When current flow through the coil stops, the magnetic field is lost. This allows the spring to push the armature and stem back to their original positions and closes the valve. When current flow starts or stops, the movement of the armature is almost instantaneous. When current flow starts, the actuator will fully open the valve, and when current flow stops, it will fully close the valve. There's no intermediate or in-between position, so there's no way that the solenoid actuator used in this example can throttle a valve. Since most solenoids operate this way, they're typically used with on-off valves. Also, solenoid actuators don't produce a great deal of force when they operate. So when a valve has to be throttled, or when more force is needed to position a valve, a different type of actuator is generally used. On a piping system diagram, a solenoid actuator may be represented by this symbol. Typically, a solenoid actuator, or simply a solenoid, is used for on-off control of a valve. When a valve has to be throttled, or when a large amount of force is needed to position a valve, such as in the case of large valves, a motor-operated actuator, or simply a motor operator, may be used. A motor operator consists of a motor and a set of gears that turn the valve stem to open or close the valve. It also has a hand wheel, a lever, and switches. This particular motor operator has two types of switches connected to its gears, a limit switch and a torque switch. When this motor operator is energized to reposition a valve, the motor drives the gears. The gears move the valve stem to position the valve. The lever is used with the hand wheel to position the valve manually in the event of a problem with some other part of the motor operator. On this type of motor operator, depressing the lever disengages the motor from the gearing and connects the hand wheel to the valve stem through part of the gearing. The limit switch and the torque switch in the motor operator ensure that the valve is positioned without damaging the valve or the motor operator. The torque switch deals with the torque, or the amount of turning force produced by the motor operator. The torque switch cuts off the current to the motor when the torque, or turning force, produced by the motor operator reaches a preset amount. Ideally, the torque switch limits the force on the valve stem to prevent damage, but at the same time ensures a tight seal between the valve disc and seat. Also, if an obstruction blocks stem movement in a valve, a properly set torque switch can cut off the motor before damage occurs. While a torque switch cuts off current to the motor when the turning force reaches a preset amount, a limit switch cuts off current to the motor when a valve reaches a preset position. The limit switch allows the actuator to move the valve stem only within a certain desired range. For example, the limit switch on this motor operator shuts off the current to the motor when the valve is fully open. Now, even though a motor operator consists of many different components, it's usually represented by a single symbol on a piping system diagram. This is one example of a symbol that may be used to represent a motor operator on a piping system diagram. Hydraulic actuators generally develop more force than similar-sized air-operated actuators. That's because some of the force exerted on an air-operated actuator is used up in compressing the air in the actuator. Liquids, on the other hand, aren't compressible for the most part, so more of the force exerted on the hydraulic fluid goes directly toward positioning the valve connected to the actuator. The power supplied by hydraulic actuators makes them very suitable for the operation of large valves. This hydraulic actuator consists of a cylinder, a fluid port at the base of the cylinder, a vent, a spring, a piston, and a piston rod, which is connected to the valve disc. In this example, when there's no fluid pressure against the piston, the spring keeps the piston at its lowest position in the cylinder, and the valve is closed. When fluid flows through the port into the cylinder, the piston moves upward. As it moves, the piston compresses the spring and opens the valve. Any air in the cylinder above the piston is exhausted through the vent. When the flow of fluid stops, the fluid pressure and spring hold the piston and the valve at their new positions. Now, when the hydraulic fluid pressure is decreased, the spring forces the piston down, closing the valve, and bleeding fluid from the cylinder. The piston can be positioned anywhere in the cylinder by controlling the amount of fluid entering the cylinder or bled from the cylinder. This actuator is considered to be single-acting because fluid enters the cylinder through only one port and acts on only one side of the piston. It's also described as spring return because a spring forces the piston down to close the valve. If hydraulic fluid pressure is lost, the spring will cause the valve to fail closed. On a piping system diagram, a single-acting hydraulic actuator may be represented by this symbol.